It is given the next information. This question asks you to examine the nature and the number of intersection points of a graph of y is log ax, where a is real positive, a is not 1, and the line y is x for particular sets of values of a. In this question, you may either use the change of logarithm base formula, this one, it is given in a data booklet actually, or a graphic display calculator logarithm to any base feature. The function f is defined by f of x is log to the base a of x, where x is real positive and a is also real positive, a is not 1. A, consider the cases a is 2 and a is 10 on the same set of axes. Sketch the following three graphs. Y is log 2x and log 10x, and y is x. 4 marks, and also clearly label each graph with its equation and state the value of any non-zero x-axis intercepts. Okay, without any calculators, we know that in general log to the base a looks like this. It passes through 1 0, and if base is greater or equal than 1, it looks like this. So it's log ax when a is greater than 1. When a is greater than 0 and less than 1, it looks like this, but also passes through 1 0. So it's also log ax, but when a is greater than 0 and less than 1. And let's compare log, for example, let's consider log 2 8 and log 8 8. Log 2 8 it's 3, and log 8 8 it's 1. And we can see that for greater value of the base, y value is less. So graph log to the base 10 will be lower below the graph of log to the base 2 of x. Actually, it's not necessary here. You can deduce this directly from the calculator, but it's useful to know in general. So let's use a calculator and plot the required graph. So y is the x, it's a line at 45 degrees. Y is the x, passes through 0 0, x y. And actually, I don't want to waste time. You can easily plot log to the base 2 of x and log to the base 10 of x, and they both passes through 1 0, and log to the base 2, it looks like this, and log to the base 10, it will be below here and closer to y axis here, something like this. So its y is log to the base 2 of x, and its y is log to the base 10 of x. And that's all for this question. In parts B and C, consider the case where A is E. It's approximately 2.7. Note that ln x, it's a log to the base E of x. B, use calculus to find the minimum value of the expression x minus ln x, justifying that this value is the minimum, 5 marks. So we need to find the minimum, and we know the required condition is that derivative must be 0. So let's find dy dx. Derivative of x is just 1 minus derivative of ln, it's 1 over x, and it must be 0. And just solve for x. X minus 1 is 0, so x is 1. And if we substitute 1 into function, we get that it becomes y of 1, it's 1 minus ln of 1, which is 0, so it's 1 minus 0, it's just 1. So 1 is 1 and 1 is the required point, and we need to show that it's minimum. And how to do that? There are two ways. We can consider the second derivative, or consider the point a bit to the left, a bit to the right, and show that the first derivative changes sign. But let's consider the second derivative. It will be much easier. So the second derivative becomes, it just derivative of 1 is 0 minus 1 over x. It's x to negative 1, negative 1 multiplied by x to negative 2, but minus minus, so it's just plus 1 over x squared. And the second derivative at point 1, it's greater than 0, and it indicates that if the second derivative is greater than 0, it shows that function is concave up at this point, and if function is concave up, so the stationary point by definition, it's just a point where derivative is equal to 0, but it may be maximum or minimum or neither. But since the second derivative is greater than 0, hence at 1, 1, hence there is, hence 1, 1 is a minimum point. Okay, next, C, hence deduce that x is greater than ln of x, 1 mark. Since at 1, 1 there is a minimum, it means that all y values are greater or equal than 1, or it's enough to say that that y values of a given function x minus ln x are just positive. Definitely, if y values are greater or equal than 1, they are positive. Or you may consider x minus ln is greater or equal than 1, and anyway, so x is greater than ln, and here also x is greater than ln. The next, D. There exist values of a for which the graph of y is log to the base a of x, and the line y is x, do have intersection points. The following table gives 3 intervals for the value of a interval, so it is given a from 0 to 1, number of intersection points, it's p, and for a greater than 1 and less than 1.2, number of intersection points, it's q, and for a from 1.5 to 2, there are r intersection points. By investigating the graph of y is log ax for different values of a, write down the values of p, q, and r, 4 marks. Definitely when a is greater than 0 or and less than 1, this situation looks like this, such log looks like this, and y is x looks like this, and definitely there is only one point of intersection. But let's check with the calculator, or you may deduce directly from a calculator, and definitely there are the same number of points of intersection for a given interval, so it's enough to consider some specific value away from a given interval. For example, here we can consider a to be 0.5, and we can see that there is only one point of intersection. And so when here a is greater than 1 and less than 1.4, not 1.2. Yes, and for the second interval we can consider a to be equal to 1.2, window x from 0.1 to, for example, 20 y values, and we can see that there are 2 points of intersection, so q is 2. And if a is in between 1.5 and 2, let's consider a to be, for example, 1.7, and we can see that it goes below y is x, and hence there are no points of intersection. And let's check for a is 0.5, and you can see that there is only one point of intersection. Okay, next, in parts E and F, consider a is real positive and a is not 1. For a is greater or equal than 1.4 and less or equal than 1.5, a value of a exists such that the line y is x is a tangent to the graph y is log to the base a of x at point P. E, find the exact coordinates of P and the exact value of a, 8 marks. So this situation looks like this. This line y is x is a tangent now. So it means that our log just touches this line at single point, something like this. So it's y is x, it's the required point P, and we also need this point, so let coordinates be 0, x0, y0. And we know that gradient of a tangent is equal to the derivative at the point where this tangent is drawn. What does it mean? It means the derivative of a function, and this is y is log ax, this function. So derivative at point x0 is equal to the gradient of a tangent, and tangent is y is x. It's a usual straight line over form mx plus c, so gradient is 1. So gradient is 1, so derivative at the required point is equal to 1. Let's find derivative. We know that derivative of ln is just 1 over x, but in general for any base there is another formula that is given in a data booklet, and derivative is 1 over x and additionally ln a. And So derivative at point x0 is 1 over x0 ln a, and it must be 1. And we need just solve it. And we can see that x0 is what? Just 1 over ln a, and we can see that point P also belongs to y is x, and also belongs to y is log to the base a of x. We can use it, and so since y is x, y0 is also 1 over ln a, but we need a. How to find a? Since this point x0, y0 belongs to this function, to the graph of this function, y is log ax, we can substitute for x for y and get an equation. So it becomes 1 over ln a, its y is log to the base a of x, but x is 1 over ln a, and we need to solve it for a. How to do that? First of all, you can see that 1 over ln, it's ln to negative 1, so it's log a of ln away to the power of negative 1. We can just flip this fraction, and we know that this power goes in front, so we can rewrite it as negative log to the base a over just ln. Actually, this can be flipped, but how to get rid of this ln, how to undo this ln? And if you remember, it was given that we should use this formula. It's actually, this formula is given in a data booklet. It's that log AB is equal to log B is here, A is here, and we can choose absolutely any base. If you choose C to be E, it becomes ln. So let's try. So it becomes minus, and it becomes, according to that formula, it becomes log. We can choose absolutely any base. This becomes here, and this becomes here. And definitely there is a hint, because it given in terms of ln. Let's choose E as base here, and it becomes just minus ln of ln a divided by ln a. But notice that what is the left hand side, it's also 1 over ln. So I can rewrite it again, this here, to be more clear, ln 1 over ln, and we can see that we can multiply both sides by ln a, and it becomes ln of ln a is negative 1. Just move this minus to the right. And just by definition, how to undo any log, base to the power of this is equal to this. So base is e, so e to negative 1 is ln a. So ln a here is just 1 over e. And again, how to undo? Ln e to the power of this is equal to this. So e to 1 over e is a, and it's the required value of a. So that y is x is a tangent to a given graph of a function y is log to the base a of x. And we need coordinates. Coordinates are here, so it becomes x 0 y 0 becomes 1 over ln e to the power 1 over e, 1 over ln e to 1 over e. And we can see that we can simplify it. And again, it goes in to front of ln, so it becomes 1 over e ln e, and ln e, it's log to the base e of e, it's just 1, so it becomes 1 over e, and it's just e, so it's e. So the required coordinates of a point P are e and e. So P has coordinates e and e. And that's all for this question F. Write down the exact set of values for a such that the graphs of y is log ax and y is x have two intersection points, and no intersection points. And we remember that the greater base is the lower a graph of log e. So definitely if a is greater than this value when graph just touches a line y is x, definitely there will be no points of intersection. So here a must be greater, strictly greater, because when it is equal to, it will be a tangent, so it's greater than e to the power 1 over e. It's our a value. And 2 points of intersection, and we remember that a cannot be 1 at all, and when a is less than 1, and it must also be greater than 0, log looks like this, and there is only 1 point of intersection always. And definitely if a is greater than 1 and less, again strictly less, because when it is equal to, it's a tangent, only 1 point, and we need 2 points less than this value. When y is x is a tangent, there will be 2 points of intersection. And that's all for this question.